Imagine you're at a loud party, music thumping, voices overlapping, glasses clinking. Someone across the room says something to you, but a burst of noise swallows the middle of their sentence. And yet somehow, you heard every word. You didn't ask them to repeat themselves. You didn't even notice anything was missing. So here's the question that should unsettle you just a little. Did you actually hear those words? Or did your brain quietly invent them for you, without asking permission? What just happened inside your head has a name. Scientists call it the phonemic restoration effect. It's the brain's ability to reconstruct missing speech sounds, filling in the gaps of an auditory signal, using nothing but context, expectation, and its own deep knowledge of language. And here's the first strange part. This isn't a glitch. It isn't your brain making a mistake. It's actually one of the most sophisticated things your mind does, running silently in the background every single time you listen to someone speak. The phenomenon was first described in careful scientific terms when researchers played recordings of spoken sentences to listeners. Sentences where one sound, one phoneme, had been physically cut out and replaced with a burst of noise. Not silence, noise. What happened? Listeners reported hearing the complete, uninterrupted word, not just roughly, perfectly. The missing sound was, to their ears, fully present. They weren't guessing. They genuinely experienced a sound that the recording never contained. You've experienced this yourself, probably today. Every conversation in a noisy environment, a busy street, a restaurant, a classroom, is filled with acoustic holes. Sounds get swallowed, syllables get masked. Your ears are constantly receiving an incomplete signal, but your brain doesn't hand you an incomplete experience. It smooths everything over. It makes the world of language sound seamless, even when the raw audio is full of gaps. The question is, how? Neuroimaging studies have revealed something almost eerie about this process. When your brain fills in a missing phoneme, your primary auditory cortex, the very region that responds to actual sound, fires in a pattern almost identical to what it would produce if you had genuinely heard that sound. Not a faint echo of the real response, a genuine, full neural signature, which means, at the level of your brain's hardware, the restored sound and the real sound are effectively indistinguishable. You didn't mishear. Your brain manufactured a perception from scratch. Two regions of the brain are especially involved. The superior temporal gyrus, a ridge of cortex wrapped around the side of your brain, is where much of speech processing happens. And the inferior frontal gyrus, tucked further forward, is tied to language comprehension. These two areas are constantly in conversation during phonemic restoration. One is reading the incoming acoustic signal. The other is cross-referencing it with everything you know about language. Together, they negotiate what you hear. Here's where it gets philosophically interesting. For a long time, people assumed hearing was passive. Sound enters, brain receives, experience happens. But what phonemic restoration reveals is something far more active. Speech perception is a two-way street. Scientists call it a blend of bottom-up and top-down processing. Bottom-up, the raw acoustic data arriving from the world. Top-down, your brain's existing knowledge of words, grammar, and context rushing down to shape what you perceive. Your experience of sound is not a recording, it's a construction. And context matters enormously. Your brain doesn't fill in just any sound. It fills in the right sound, the one that makes the sentence make sense. If you're listening to someone talk about a walk in the park, and a burst of noise swallows a word, your brain will steer toward a restoration that fits the story. Change the context, change the conversation, and the same acoustic gap might be filled with a completely different phoneme. Expectation and prior knowledge are shaping your reality in real time. But here's the twist that changes the picture entirely. Research from neuroscientists at UC Berkeley found that the hippocampus, the brain region most famously associated with memory, also plays a role in filling in the blanks of language. The hippocampus, the same structure that helps you remember where you left your keys, is also helping you hear words that weren't there. This links language perception directly to memory systems, suggesting that when your brain restores a missing sound, it's drawing on stored linguistic experience, everything you've ever heard before. And it's not just sound. When you read, your brain does something remarkably similar. Studies show the brain processes words as whole units, recognizing familiar words rapidly and efficiently, rather than decoding them letter by letter every time. Your mind has built a vast internal library of patterns. The more you've heard a word, the faster and more confidently your brain can restore it if part of it goes missing. Experience literally sharpens the restoration. The more language you've absorbed, the better your brain gets at filling the gaps. Now consider what this means for your daily life. Every misunderstanding you've ever had, every time you were absolutely certain someone said something they swear they didn't, might not have been a memory failure or careless listening. It might have been phonemic restoration working perfectly, but filling in the wrong word. Your brain heard a fragment, matched it against your expectations, and delivered a confident, fully formed perception. You couldn't tell the difference because neurologically, there was no difference to tell. This has real stakes. Eyewitness, or rather ear witness, testimony has long been considered unreliable in legal and forensic settings. Phonemic restoration is one reason why. A person may sincerely, genuinely believe they heard a specific word or phrase, and their brain's own neural response will back them up completely, when the acoustic reality was ambiguous or even different. The brain doesn't lie to you. It just doesn't always tell you when it's improvising. And here's the deeper reflection. We tend to think of perception as a window, something transparent that shows us what's actually out there. But phonemic restoration is one of many pieces of evidence that perception is more like a painting. Your brain is an artist, constantly composing a coherent, meaningful experience out of noisy, fragmentary raw material. It is extraordinarily good at this. Most of the time, the painting matches the world, but not always, and you will rarely, if ever, know the difference. So the next time you're in a noisy room, following a conversation effortlessly while chaos surrounds you, pause for just a second. Because what feels like simple listening is actually an astonishing act of neural construction. Your brain is predicting, pattern matching, drawing on memory, recruiting multiple cortical regions simultaneously, and delivering you a seamless experience of language. All in milliseconds, all without your awareness, all to keep you connected to the world of meaning. It's not a flaw in the system, it is the system. And it raises one final question worth sitting with. If your brain is always filling in what it expects to hear, how much of what you believe you've heard in your life was real, and how much was beautifully, silently invented?